Softing.
In this video, we are going to explain some commonly used terms when performing fiber optic cabling test. In general, there are two types of fiber optics: the single mode and the multimode. The main difference between the two types is the number of light modes that can be propagated. Mode refers to the path of the light that travels down a fiber cable, or the number of signals per fiber. When light is transmitted from a source, it is not reflected many times in a single-mode fiber, keeping attenuation to a minimum, but is reflected many times in a multimode fiber, causing high attenuation or loss. This is mainly due to the difference in core diameter of the fiber. A single-mode fiber has a typical diameter of 9 microns for OS1 and OS2 cables. A multimode fiber can have diameters of 62.5 microns for OM1 cables, and 50 microns for OM2, OM3, OM4 and OM5 cables. Micron is an abbreviation for a micrometer, or a millionth of a meter. OS refers to optical single-mode fiber, and OM refers to optical multimode fiber. The numbers that follow the OS and OM refers to the different data rates, wavelengths, distance, and attenuation specifications. Light is defined by its wavelength, and the length of a wave has a direct relationship with its attenuation. The longer the wave, the lesser the attenuation. Single and multimode fiber operates at different wavelengths, 850 nanometers and 1300 nanometers for multimode, and 1310 nanometers and 1550 nanometers for single mode. Due to the large core size, some low-cost light sources like light-emitting diodes, or LEDs, and vertical cavity surface-emitting lasers, or VCSELs, that works at the 850 nanometers and 1300 nanometers wavelengths are used in multimode fiber cables. The single mode often uses a laser, or laser diodes to produce light injected into the cable. As multiple modes or light's path travel down a multimode fiber cable, it can offer high bandwidth, but over a shorter distance due to its higher attenuation. When multimode runs over longer distances, modal dispersion occurs. Modal dispersion effect has an inverse relation between the fiber bandwidth and reach distance. The reach distance decreases as signaling bandwidth increases. Single-mode fiber has a smaller core size that permits only one mode of light to be transmitted. Single-mode fiber carries a higher bandwidth and can be run over a much longer distance than multi-mode, but it requires a light source with a narrow spectral width. Single-mode fibers are more delicate to terminate and are often more costly. A single-mode and multi-mode fiber can also be differentiated physically. According to the standards, for non-military applications, single-mode cable is coated with yellow outer jackets, multimode is coated with orange for OM1 and OM2, and aqua for OM3, OM4 and OM5. Have a look at the other videos or visit our website to explore the other various features of Wire Expert. Thanks for watching.